In the previous video, I introduced what we mean by simplifying radical expressions. And the one thing that we focused on in that video was the fact that in simplified radical form, we don't have perfect roots inside of radicals. In this video, we're going to focus on what do we do if we have roots in a denominator. So that's our purpose here. So let's go ahead and take a look at something that would fit this description, right? Let me bring this. I apologize for that. Let me bring this off the screen and bring this problem on the screen. So in this one, you can see I've got the square root of, I've got 5 divided by the square root of 2. And it's not a problem that I have radicals in the final form. In fact, it's going to be necessary. What's the problem is that we don't want to have a radical left in the denominator. So to simplify this, what we do is we make the denominator, instead of it being a radical, we're going to rationalize it. We're going to make it a rational number. Well, and to do that, it's not very difficult because we're essentially going to multiply this by a big 1, right? We're going to multiply it by the number 1. And in our denominator, we're going to have the square root of 2, and in our numerator, we're going to have a square root of 2. And I think you can see the reason why I picked root 2 for the denominator is because if I multiply this square root of 2 times the square root of 2 I picked, I'm going to have the square root of 4, which is 2. And of course, the reason why the numerator had to be a root 2 is because that's what makes this the number 1. Root 2 divided by root 2 is equal to 1. So if I do this, right, my denominator now is going to equal to root 2 times root 2, which is just plain old 2. And my numerator is going to be 5 times the square root of 2. Now, just to verify that these are exactly the same numerically, let's consider these on our calculator. So let me clear the screen, and let's look at 5 divided by the square root of 2 for the first instance, and that's 3.535533. You can see the decimals. And now let's take a look at 5 times the square root of 2. And then once I've got that, I'm going to divide that by a 2. And when I enter that on my calculator, you can see I get the exact same decimal. So these are absolutely the same, right? 5 over the square root of 2 is exactly the same thing as 5 root 2 over 2. But the reason why we consider this simplified radical form is because we've gotten rid of the roots in the denominator. That was the second thing, right? No perfect squares inside radicals and no roots inside denominators. Let's look at another example. So for the second example, I've got 2 times the square root of 6 divided by the square root of 2. And I don't think it's going to come as much of a surprise, but I'm going to multiply this by the number 1 to change its form, but not change its value. And again, looking at my denominator with a radical 2, I'm going to multiply by root 2 over root 2. When I do that, this becomes, I can write this as 2 times the square root of, 6 times 2 is 12. And remember, the reason why I can combine those, right, the reason why I can bring them together is we know that the square root of a times b is the same thing as the square root of a times the square root of b. So I'm just looking at this in this direction, right? I'm multiplying 2 radicals and putting them inside of one radical symbol. And then my denominator is root 2 times root 2, which is a 2. Which is interesting because I now have a common factor of 2 in both my numerator and denominator. So I can now write this as the square root of 12. And we'd probably be happy with that, except it's violating one of our other things that we consider important for simplified radical form. It turns out that there is a perfect square inside of that radical. So I'm going to go ahead and write 12 in its prime factored form. That's 4 times 3, so I could write it as 2 times 2 times a 3. 2 times 2 is 4 times another 2. 2 times 2 is 4 times the 3 is 12. And if I break this up, this is the square root of 2 times the square root of 3. The square root of 2 is the square root of 4, which is just 2 times the square root of 3. So this is my final simplified form. And you can see where I started here. Let me write this down right here. 2 root 3 is what my answer is. And I want to demonstrate this one again with the calculator, just because it's a good way to check when you're doing these initially, just to see if you get the right idea. So if I take and multiply 2 times the square root of 6, let's see, square root of 6, and then divide that by the square root of 2, that's 1, right? That should be equal to 2 times the square root of 3. 2 times the square root of 3. And they're both exactly the same decimal. So this is simplified radical form, right? 2 root 6 over root 2 is equal to 2 root 3.